So thanks, Dragos. Thanks for the introduction. Thanks for stealing my punch. So we'll be talking about that today. Before I start, maybe I'll take my 10-second piece, little pitch to tell you a bit more about Element AI. So at the core, Element AI, we're an enterprise software company, but we're not your typical enterprise software company. We build software on a very strong AI stack. We believe that building strong machine learning components is what will allow us to build a better products in the future. And in order to do that, we have really strong connections to universities, to academia. We have internal fundamental research. We have internal applied research. And we go all the way to the core components in the products. It's a very interesting way to build software based on machine learning. And if you're interested, you can check us out. We're here in Toronto, also in Montreal, and London, UK, and Seoul, and Singapore, if you want to travel. Okay, so today we're going to talk about AI for a complex work. So a number of ideas in there are really deep to my heart, really important things. And it's talking a bit more about how us as a community can help drive AI in an interesting and impactful direction in the future. So let's start with the concept of Homo Faber. Who here has heard that term before? Raise your hand. Not that many philosophy students here. Good. So Homo Faber is a concept in philosophy. It dates back to roughly 300 years before Christ. Roman philosophers introduced it. And it's essentially the idea that as humans, what defines us, in part at least, is that we have the ability to create artificial objects. We create new stuff all the time, right? And as humans, what defines us, we started developing that neocortex, is that we actually started building tools. And we went further. We started building tools that helped us build other tools. And doing that again and again, eventually, we're kind of using our neocortex to automate almost everything we do. This is an interesting way to look at our intelligence, what distinguishes us. However, if you look up until now, the way we've been automating stuff is a bit crude. We tend to automate things by using a relatively limited set of rules, simple mechanisms or simple rules in a software program. For example, in agriculture, the fact that we're limited to simple mechanisms in order to harvest stuff means that we have a tendency to reshape our environment in order to make it manipulatable by these crude automated machines. Right? We will plant our crops in nice straight rows so that the harvesting machine can process them. Why? Because this harvested machine is a very crude automated machine. It's only a bunch of gears, and the number of rules that it can attack is pretty limited. If you think about the way we automate manufacturing, it's very similar. You know, we have these robots, maybe, that we can use to automate manufacturing, but they operate according to very crude rules, very strict rules. And as a result, we have to build the same object again and again and again. That's how we think of manufacturing today. So we're limited in this thinking. Okay, let's look at software, right? In software, the way we think of software is typically, let's do a lot of work up front so that we don't have to do work later, right? For example, in email, so that's the case now because AI is catching up, but it used to be the case that we would organize all our emails in nice little folders by types, by whatever topics. You know, we all had our little organizational chart for our emails, bin them there. And we did that because, well, maybe in the future, when I look for that email or that information, I'm going to look for it there, right? And we still do this today with our, when we organize our files and our hard drives and things like that. You know, we don't trust the ability of the software to find it later. We pre-organize it. Why? Because the tools we use to find stuff, to connect things together, these tends to follow very crude rules. Okay, so let's dig a bit deeper into software. And this is the part of the talk, if you were at the Toronto Machine Learning Summit, I'm going to go back to what I was talking about there, okay? But taking a slightly different angle, let's see what you think of that. So on the topic of software, there is this interesting concept that was introduced by an author, he's an economist, Daniel Kahneman, who in a book called Thinking Fast and Slow introduced two different concepts of thinking. One is called System 1. This is our way to make decisions very quickly, these snappy decisions. We do that without effort. We see something, we decide to click on it. We see something, we decide to interact with it without thinking too much about it. These are our raw behaviors. Back in the days, we used to call that the lizard brain. Right? This thing where we can make very effortless decisions very quickly, sometimes emotionally. You can contrast that with another form of thinking we all have, what Daniel Kahneman calls System 2. This is a much more thoughtful way of thinking. It requires effort. It requires us to sit down and compare a bunch of options, or think deeply about who we are, what we care about, the way in which we want to evolve, what we aspire to become. This is System 2 thinking. It takes work. It doesn't come naturally. You don't do that when you're tired. You do that when you're at peace with yourself, or where you're facing a problem, and when you can sit down and think about it for real. This is our neocortex. This is the power that we have, the power to change who we are, the power to define ourselves in a way that might go beyond our immediate behaviors. Now, if you think about what software designers or what designers are taught when they're in school, when they're taught to build software, what we tend to tell them is, well, good software is software that can be used effortlessly. Right? You pull your phone, you interact with any application in there, it tends to be easy. Right? Just scroll, don't think too much. So as a result, we end up building software that are very, very good at triggering System 1 behaviors. Because everybody wants to build software that can be used effortlessly. What does that mean when we start building AI on top of that software? It means that the AI, which is basically ingesting all the data it gets from the user interaction with the software, is ingesting a lot of effortless actions, a lot of System 1 behaviors. And we train it on that. So as a result, there's like a ton of these System 1 behaviors for very few behaviors that were triggered by thoughtful, reflexive thinking. The outcome is cat videos. It is. If you think of YouTube, which is a perfect example of a software that was designed to be effortless from the beginning to the end. What happens there? You interact with a bunch of videos that you see. And you tend to interact with videos that will not require too much brain power. You just click on it, you watch it. It tends to be cute little videos, like, I don't know, cat videos. And you can then, what does the AI behind the software do with all these clicks, all these behaviors? It records them. That becomes the data that it will be trained on for the next version of the software in batch, or in real time, whatever. Next time you go to Facebook, oh, lo and behold, more cat videos. That's what your System 1 told it, right? And if you just get stuck on there, you will watch cat videos for the rest of your life. Fortunately, there's like once in a while we go to the other data point. We start using System 2 again. But anyway, it's kind of a joke, but it's an important thing to realize. We build software that are really, really good at giving us more of what we do, but that are not really good at figuring out what we aspire to do and giving us what will help us get there. Another example that is maybe a bit more troubling. There was a recent study, don't remember the name of the firm who did that, but they analyzed a bunch of people and figured out that we get disturbed by a vibrating phone, 30 to 80 times a day, right? 30 to 80 times a day, it's going to shake in your pocket and tell you, pick me up. And you know what? System 1 means, I'll pick it up. And we pick the phone up and we look at it and maybe we click on it, it's effortless, right? And we do interact with it. What are we doing when we do that? We provide data point to an underlying AI that picks it up and says, hey, that was a good idea to vibrate exactly at that time. So we get more of that, right? So again, that's not how we want to use our time. We don't want to be picking up our phone all the time and looking at what's on there. So that might be, you know, another bad example in which this, the fact that these softwares are built to be used in an effortless fashion are actually having bad results. But the next slide here is the worst example, in my opinion. It's an example that is, I think, as a society, tearing us apart. That's going to be increasingly important for us Canadians very soon as we go into election. And it's the fact that because we have software that is meant to be used effortlessly, we have software that tends to create echo chambers. If you think of our social media software today, right? What do we do there? We read some information. Okay? We click on it, we like it, we reshare it. All of this is done relatively effortlessly because the software was designed for that. All of this is done mostly with System 1, which tends to mean for news, we click, we like, we reshare news we already agree with. News that reinforce our, say, our current biases, maybe our current opinions. What does that mean? Well, there's an AI behind that listening to this and saying, oh, they like, you know, Trump stuff, or they hate Trump stuff and they like the other stuff. I'm going to give them more of that. And it goes worse, it does worse than that, right? So that this echo chamber has been studied quite a bit. There is a website you can go to on, I believe it's the New York Times, it's the Wall Street Journal, I believe, that built that. It's an app called Red Feed, Blue Feed. You go there, you click on a topic like gun control or something like that, and you will get two feeds side by side, the Facebook feed of a Democrat and the Facebook feed of a Republican. Same news stories, totally different treatments. It's amazing. The gap is huge. But what's worse is that not only is the gap widening, it's becoming very extremist. Like, Democrats read super extreme Democrat stuff or are exposed to it. Why? Because there is this effect in social network where if a news has a slight advantage, if the AI puts it slightly on top of the other news, its probability of being amplified exponentially through the resharing mechanisms, through the viral mechanisms behind social network, this slight initial advantage can turn into a huge downstream advantage for that news, right? So if a news triggers people a bit more, well, people will maybe use their System 1 to click on like a bit more, and it will get an exponential amplification. So this is why these echo chambers are turning into extremist chambers more and more. And this is true even though the people reading these news, most of us here, want to build a bridge to the other side. Our aspirational selves don't want to create this divide that is tearing us apart. Most of us here, if asked, you know, rationally in a moment of peace, how do you wish the social network was? What do you want to be exposed to? Most of us would say, I'd like a more balanced diet of news. I'd like to be exposed to the truth. Yes, I tend to click like on the stuff I agree with, but I'd much rather have a better picture of the world. And this is us thinking with System 2. This is us being aspirational. This is us defining who we want to be in the future. But the systems we're using today have been built to be used effortlessly. And as a result, the systems we use today create this division and drive us further apart. So how can we try to solve this? The first thing I think us as designers, us as software engineers, data scientists, let's talk about that. Let's talk about the fact that there exist these two systems, that people are not only their behaviors. Let's break that idea that users are their behaviors. Let's track these different interactions that we have, or at least try to track them, try to identify them. Let's rebalance. If we can track them, if we know that some interactions are system 1 and some are system 2, maybe we can lower the weights of the system 1 interaction and increase the weight of the system 2 interaction. An example I like to give here is, I go to my friend and I tell my friend on an evening, I'd like to go on a diet. Okay? No reason. And my friend's like, okay, I'm going to help you go on a diet. And the next day my friends see me eating M&Ms because, we have free M&Ms at work. That's a plug. And for every M&Ms I take, my friend's like, oh, well, all these M&Ms are a counter-example of what you told me today, right? Because this is my system 1 behavior at work. It's like colorful sugar stuff and eat it, right? But each of these user actions for the AI are considered on the exact same footing as my statement the night before when I said I wanted to go on a diet. So we can be more clever as designers, as programmers, as data scientists. We can be more clever than that, figure this out and try to rebalance it. But at the core of this issue, I think what we have to get more comfortable with is to recognize the value of effort. Trying to build software that removes any effort from the user is maybe the original sin. Because what we do without effort tends to only capture a facet of who we are. If we get comfortable with the idea that software sometimes can be useful when they require someone to think a bit harder about what they want and who they are, maybe we'll build software that are better at capturing our aspirations. Okay, so we've solved that. Good. Let's go home, party. What's next? Let's go back to these crude automated machines we were talking about, right? Let's go back to that and ask ourselves, what's the deeper issue here? The deeper issue is that I think, in some sense, we've internalized the fact that efficiency means effortlessness. That efficiency means volume. Efficiency means building a lot of the same thing. Efficiency means changing the entire environment beforehand so we can be efficient. Well, this is exactly where machine learning can help. Because before, we were stuck in a world where we had to engineer rules, and we were pretty limited in the complexity of the rules we could make. But now, we can build systems that are good at understanding their environment, capturing data about their environment, right? And these systems can be pretty complex. A machine learning system can be arbitrarily complex compared to a set of strict rules. So these crude automated machines, now maybe we can move beyond them. And we can start building machines that understand their environment and can be efficient without transforming these environments. And if you think about it, essentially, environments thrive when they're chaotic, thrive when we leave them in their, we're not forced to order them. So maybe what machine learning can allow us to do at the end of the day is maybe it can allow us to embrace the complexity in which the world we know thrives. And maybe that's how we can start solving some of the world's greatest problems, like climate change, like agriculture, all of that. Thank you.